Section 12.6 is quadratic functions. I can graph quadratic functions. A quadratic function is an equation in two variables that can be written in the form y equals ax squared plus bx plus c. In order for it to be quadratic here, it has to have an x squared as the highest term. So it has to be degree 2. In example 1, we're going to evaluate a quadratic function. We're making a table of values for our function. When we do our table, we're going to do like we've done before. We pick x values, plug them in, and find y values. We're also going to start off with the same x values we've used before. So -2, -1, 0, 1, and 2. We take these x values and we plug them in to the x's in our equation. So I'm going to have 2 times x squared plus 3 times x plus 1. So I'm going to take 2 times our x value, which here is -1, squared, plus 3 times x, which is -1, plus 1. 2 times x, which here is 0, squared, plus 3 times 0, plus 1. 2 times x, which here is 1. It's still squared, just like it is in our original equation, plus 3 times x, which again here is 1. And then we still add on the 1 from our equation. 2 times x, which here is 2. Plus 3 times x, which here is 2, plus 1. And now we calculate these. Here we get 3, which means when we plug in -2, we get 3. Here I get 0, so when I plug in -1, I get 0. Here I'm going to get 1. When I plug in 0, we get 1. Here we get 6. So when I plug in 1, I get 6. And here I'm going to get 15. So we get 15 there. And remember, these are ordered pairs of our function, their solution. Feel free to pause here and give this a try. We're going to make a table of values for the given function. So my table of values, I'm going to input x values to find y values. And again, the x values I'm going to use to start with are -2, -1, 0, 1, and 2. I plug those into the x's in my equation. So here, remember, if there's not a number in front of our variable, that coefficient is a 1. So here it's like I have -1 times x, which is -2, squared, plus 2 times x, which again is -2, plus 1. I'm going to have -1 times x squared, so -1, still squared, plus 2 times my x value of -1, plus 1. I have -1 times my x value, squared, plus 2 times my x value, plus 1. -1 times my x value, squared, plus 2 times my x, which here again is 1, plus 1. And then I'm going to take -1 times my x value, plus 2 times my x value, plus 1. Here I should get -7. So -2, -7 is an ordered pair. Here I should get -2. Here we should get 1. Here should get 2. And here should get 1. Again, my table now makes ordered pairs, -2, -7, 0, 1. Those are solutions and ordered pairs of my graph. Go ahead and pause and give 2 a try. Again, we're making a table of values. Make an XY chart, XY table. My inputs, my x values in my domain are going to be -2, -1, 0, 1, and 2. I plug those into the x's in my equation. So here I'm going to have -2 squared minus 4 times -2 plus 7. Take my x value, -1, squared minus 4 times my x value of -1 plus 7. I'm going to take my x value of 0 squared minus 4 times my x value plus 7. I'm going to take 1 squared minus 4 times my x value of 1 plus 7. And I'm going to take 2 squared minus 4 times 2, again because that's my x value, plus 7. Here, I'm going to get 19. I get 12. I get 7. Four. And 3. Those are my solutions and my ordered pairs. And give 3 a try. Make our table of values. My x values I'm going to start with are -2, -1, 0, 1, and 2. I'm going to plug those into the x's in my equation. So here I'm going to have 3 times x. That gets squared. Plus 6 times my x value. Minus 9. I'm going to take 3 times my x value. Squared. Plus 6 times my x value. Minus 9. Take 3 times my x value. Squared. Plus 6 times my x value. Minus 9. I'm going to take 3 times my x value, which here is 1. Squared. Plus 6 times my x value, again here is 1. Minus 9. And 3 times my x value. Here it's 2 squared plus 6 times my x value, which again is 2 minus 9. Here I'm going to get -9. So that goes into my table. I get -12. I'm going to get -9. Here, I'm going to get 9. And here, I'm going to get, here I'm going to get 0. Let me fix that. 3 plus 6 minus, there we go. This should be 0. And now here, I will get 15. And that gives me my solutions and my table. The graph of a quadratic function is a U-shaped curve called a parabola. A quadratic function is an example of a non-linear function. A non-linear function is any function whose graph is not a line. So non-linear, not line. Okay, we can't use a straight edge here to connect these. When a is greater than 0 or positive, the graph of the quadratic function has a minimum value, which is the y-coordinate of the lowest point on the graph. So when a is positive, we get what looks like a happy face parabola. It opens up, and we have a lowest point. We call that our minimum value, and the value is the y-coordinate of that point. That point we call the vertex. When a is negative or less than 0, we have a sad face parabola. The highest point is the maximum value, and that's the y-coordinate of the highest point. Okay, just the y-coordinate. It happens at the vertex is what we call that point, but the y-coordinate is that maximum or minimum value. So in examples 2 and 3, we are going to graph these and then determine whether they have a maximum or minimum value. We can tell by looking at the equation whether or not they should have a maximum or minimum, but then we can graph them to double check. So here it's a positive in front of my x squared, which means this is going to be a happy face parabola, and we should have a minimum. But let's graph it and double check. So in order to graph it, we're going to do our table of values. I'm still going to pick -2, -1, 0, 1, and 2. Here I went ahead and plugged our values in, since we've done that a couple times now. I get 3, 1.5, 1, 1.5, and 3. Now, these are ordered pairs. We can graph these points. Okay. So at -2, 3, -1, 1.5, 0, 1, 1, 1.5, 2, 3. I'm going to connect these with a U-shaped curve. That lowest point is called our parabola. These don't have to be perfect, guys. What I'm going to be looking for is to make sure you try and make them curved and try and go through your points, and then to see where your points are at. So our graph should look something kind of like that. And if we look here, we have a minimum value. We have a smallest point. Okay, and that minimum value is 1, the y-coordinate of our lowest point. I'm going to stop this one here and continue on in another video just for time's sake.